What's up everyone, Patrick here, welcome back. And in this next question, what we got to do is we got to solve for x, y, and z, and notice that we're given three equations. So three equations and three unknowns. Now there's multiple ways you can go about this. You can put this in a matrix if you want. You can also do it algebraically. And in this particular example, I'm going to go about it algebraically. So what I'm going to do is I'm first going to isolate for one of the variables in one of the equations, and then I'm going to plug in that expression that we have for that variable in the other two. So what that will do is we'll end up having two equations and two unknowns that we can solve for. And the variable that I'm going to isolate for, you could pick any you want yourself. You can do this in multiple ways. Just make sure that whatever answer you get at the end is the same as the answer that we're going to get in the video. So what I'm going to do, the variable I'm going to isolate for, we can isolate here. I'm actually going to isolate for this x over here. And the reason why is because there's no constant. So when I bring the x over, notice that I'll have 5y minus 5z is equal to x. And this is nice because there's no constant here. And so when we plug in this expression into this x and that x, there's just going to be less expanding to do. So for example, let's say that we isolated for this x instead. We bring the y over, bring the z over, then we have to worry about this 2 when we plug it into this x and this x as well. You can go about it that way. It's just here we don't have a constant to worry about. So I feel like this is a nicer, smaller expression to plug in for the other x values. And so when we do that, if we let me plug it in here. This x value, we're going to plug in this, so we'll have 5y minus 5z plus y plus z is equal to 2, like that. And then if we simplify this, notice that 5y plus y gives us 6y, and then minus 5z plus z would give us minus 4z. And that's going to equal 2. Like that. And notice we could simplify this even further. We could divide everything by 2. So we would have 3y minus 2z is equal to 1. Right? So that's one of the equations that we're going to have. Now if I take this and plug it into this second equation for this x, we'll have 4 bracket 5y minus 5z plus 3y plus 2z is equal to negative 3, like that. And so from here, expanding, we would have 20y minus 20z plus 3y plus 2z is equal to negative 3, like that. And then simplifying all the like terms, 20y plus 3y would give us 23y. Then negative 20z plus 2z would give us minus 18z, and that's going to equal negative 3, like that. All right, so now notice we have two new equations and only two unknowns. So now what we can do is we can solve these two variables, y and z, with substitution or elimination. And what I'm going to do is I'm going to use elimination. So what I'll do is I'm going to multiply this by 9 to get the coefficients in front of the z the same. So if I multiply everything by 9 here, sorry, I'm kind of going all over the place here. So if I take this, multiply it by 9, we'll have 27y minus 18z, right? That's what we wanted, these to be the same. And then this would end up equaling 9. So now what we can do is we can take this and subtract it from that. So notice when we do negative 18z minus negative 18z, that'll be like negative 18z plus 18z. Those would go away. 23y minus 27y would give us negative 4y, and then negative 3 minus 9 would give us minus 12, like that. And now notice we could just solve for the y. Divide both sides by -4, so y would end up being 3. So we have the y value, and then this y value we could plug in here to solve for the z. I feel like it's easier than plugging it in here, but it doesn't matter, you'll get the same answer whichever way you go. So we'll have 3 times 3 minus 2z is equal to 1. This would be 9, bring the 1 over, so 9 minus 1 would be 8. That's going to be 2z, positive 2z, divide both sides by 2. Z would be 4. And then we have the y and then the z, and then you could take those two and plug it into one of the original equations. I feel like this one is the easiest one to plug in. So we'll have x plus 3 plus 4 is equal to 2. So this would be 7, bring it over, 2 minus 7 would be -5. All right, so x is -5, y is 3, z is 4. And then if you want to take this and you want to check your answer, you could take these values, plug them into the equations to all three, make sure that left side is equal to right side, and it should all pan out. So those are the final values for x, y, and z, and there's a unique solution.